All right, guys, welcome back. Day 13 of the 100 Days of LeetCode. Today we're going to be doing an easy problem that a lot of people struggle with. It's only got a acceptance rate of, I believe, about 31%, something like that. So, yeah, let's get right to it. It's going to be problem 941, valid mountain array. So, the explanation reads, given an array of integers, R array, return true if and only if it is a valid mountain array. Recall that R is a mountain array if and only if array.length greater than or equal to 3, there exists some I with 0 less than I less than array.length minus 1 such that array 0 less than array 1. You can read this yourself, but basically what this means is that it's strictly increasing, meaning we have no values next to each other that are equal, and then it peaks somewhere. So in this case it peaks at 5, and then on the other side of that peak there are some values that are strictly decreasing. So here we have an example of what I was just talking about. It's increasing but not strictly because we have 2 3s in a row, so this is not a mountain array. And they have some examples here, which is false. This is not a mountain array because there's nothing to the left of 2 that is smaller than 2. This is not a mountain array because, for 2 reasons. One, because we have 2 equal values and there's nothing on the other side here. And then this is a mountain array because 0 is less than 3, 3 is the peak, and then 2 is less than 3, 1 is less than 2. So let's get to coding it. All right, so the first thing we want to make sure is we're going to check for this. So we simply do if length array less than 3, let's keep it on one line, return false. Oops. I got mixed up between Python and Java. False is capital in Python. So that we do that, so just right away we check. Now again, Python and Java confusion. We need to create 2 pointers here, and one we can just call the left. That's going to be equal to 0, and then one we can call R for right, and that's going to be equal to the length of array minus 1. Okay, so that's the last index in the array. Now we want to basically iterate each of those pointers until they're either at the second last or second index, or the condition in terms of greater than or less than is false. So it'll make more sense when I show it to you. So here we can say while L is less than the length of array minus 2. So the last index of the array is the length of the array minus 1. The second last index is the length of the array minus 2. Now, we don't ever want a situation where we iterate increment L all the way to the last index of the array, because that case isn't valid. It would not be a mountain array if this left pointer gets all the way to the last index. So you'll see in this AND statement, we do array L less than array L plus 1. And then we're simply going to add up increment L each time. And we do the same thing, just opposite, for R. So we say, well, R is greater than 1 and array R is less than array R minus 1. R minus, we decrement R. And we're simply returning L equals R. Now, if we did, say here, minus 1, and here we did greater than 0, it would be possible that these would equal each other at either the first or the last index. And we don't want that because we've already established that it can't be a mountain array if sort of the maximum value is in either of these indices. So that's why we need to stop this iteration but before we get to the second last index. And now our code should work. There you go. So that's how we solve valid mountain array. That was day 13. We got another 87 days of 100 days of LeetCode. If you guys enjoyed that, please like, subscribe. See you tomorrow.